This beverage costing exercise is part of a workshop that was offered in St. Kitts and Nevis during February 2016. Financial support for this workshop from the Inter-American Institute for Cooperation on Agriculture, IECA, is gratefully acknowledged. I would personally like to thank Mr. Augustine Merchant, IECA representative in St. Kitts and Nevis, and the IECA staff for their considerable efforts in making this workshop possible. We will begin with a brief introduction, followed by a sample costing exercise. Then we will look at taking cost-effectiveness measures and how to cost reduce your production. During the workshop, we followed all of this up with a brief discussion. One of the most difficult things to do for those of us who do not have a business background is to determine the cost at which we should be selling our product. We will take a look at the contributing factors in this exercise. As we begin our beverage costing exercise, I would remind you that all values are purely fictitious. We will assume that there are 8 ounces by weight per container and 25 containers per carton. We will also assume that there are no losses in processing. Normally, you would sell your product by volume, for example, 250 milliliters per container or approximately 8 fluid ounces per container. However, for batching the product, your formulations are usually based on the weights of each ingredient. Water may be the exception to this, as it is often easier to start with a measured volume of water, but you do need to know the weight of this water. Then you will add the other ingredients to the water based on their weights. If your formulations are based on the weight percent of each ingredient, you can then customize the size of a given batch to give a certain volume of final product. To do this, you must know the density of your beverage. The density of a beverage with 10% sugar in it, by weight, is about 1.04 kilograms per liter. Dividing the weight of your batch in kilograms by the density of the beverage in kilograms per liter will give you the number of liters of beverage. So let's take a look at 2 density-based calculations. If the density of your beverage is 1.04 kilograms per liter, then let's calculate the volume of 250 kilograms of it. We begin with the formula that the volume is equal to the weight divided by the density. Using dimensional analysis, we'll draw a horizontal straight line, and then we'll put the weight on top at the left. The next term in our equation is to divide it by the density of 1.04 kilograms per liter. At this stage, we can cancel out the kilograms and are left with units of liters. Then we can do the number crunching, and we find that the volume of 250 kilograms of beverage is 240.4 liters. In the second calculation, we're going to take the beverage density to be 1.04 kilograms per liter once again, and we're going to calculate the weight of 175 liters of this beverage. So the weight will be equal to the volume times the density. We'll then do a dimensional analysis calculation where we take 175 liters and multiply it by 1.04 kilograms per liter. The liters will cancel out and we're left with kilograms. The numerical value then is 182 kilograms. So 175 liters of this beverage will weigh 182 kilograms. For our sample costing exercise, we will not get excessively technical. Please remember that the values used in these calculations are totally made up. You can substitute your actual values to get a better indication of your own costs. So here we have a listing of the raw materials. The ingredients are down the left: mango pulp, water, sugar, citric acid, and flavoring. Then we have a cost per pound of each one of these. And please don't forget to include a cost for water. Water is not free, regardless of what you think. We then have the number of pounds per batch, or in cases where you're using the metric system, we could do things with regard to kilograms. Once we know the cost per pound of each ingredient and the number of pounds per batch, we can figure out the cost of that ingredient per batch. And in this slide, you will see that in order to make 100 pounds per batch, we require $144.24. The labor component is made up of a manager and 2 staff members. If it takes an hour and a half to make each batch, we will have to pay the manager 1.5 hours of salary at $15.5 per hour for a total cost per batch of $23.25. 2 staff members working for an hour and a half each will total 3 hours per batch at $12.50 per hour, and that means that the cost of the staff members will be $37.50. This gives us a total cost per batch of $60.75 for the labor component. The next thing we're going to examine is packaging. This will include the bottles, the lids, and the labels for the beverage, and the cartons in which we will put the bottles once they are ready for shipping. The cost of each bottle and each lid, each label, and each carton is given in the second column from the left. The number of each of these per batch is given in the third column. We need 200 bottles, lids, and labels, and because there are 25 bottles per carton, we only need 8 cartons per batch. We have the unit cost of each of those there. Then we can multiply the unit cost times the number per batch to get the total cost of each component per batch. And as you can see here, the total cost of packaging is $76.24. There are overhead costs that we incur in doing business. We have fixed and variable costs. The fixed costs total $25.75 per batch, and the variable costs amount to $10.57 per batch, for a total of $36.32. Your fixed costs are those that are the same no matter if you are making the beverage or not. They would include the cost of borrowing money to finance new equipment or facilities, the taxes on your facility, and other things that are involved in just having the facility available. These are the bricks and mortar type things. Your variable costs are those that change with the amount of material that you use and the amount of beverage that you make, or that just seem to pop up. They could include the cost of electricity to run your equipment, and may also include things like office supplies, cleaning supplies, and the like. You may also want to include telephone expenses in here as variable costs, if that is part of the cost of doing business. You may also want to put some contingency costs in just to cover unexpected expenses. You might say that these are 10% of your total overhead, or some other way of factoring them into the situation. We now have transportation and warehousing costs, which I've termed as being T&W. We're basing those on a per carton cost of $3.75. There are 8 cartons in each batch at $3.75 each, so the total cost of transportation and warehousing per batch is $30. Now we can add all of these costs up: the raw materials, the labor, the packaging, the overhead, and the transportation and warehousing. When this is done, we get a grand total of $347.55 per batch. The total cost per batch, being $347.55, can then be spread over each container to find the unit cost per container. Since we have 200 containers per batch, the cost per container is $1.74. Now we're going to introduce the concept of a margin at 25%. So we're going to say that we want to make a profit of 25% on each container. 25% of $1.74 will then raise the cost to $2.17 per container. So the 25% margin amounts to 43 cents per container. Here's a cost summary then that we had before, and now we're going to look at it on the basis of the percentage cost of the total. So the raw materials cost 41.5% of the total cost per batch. The labor amounts to 17.5% of the total cost, packaging is 21.9%, overhead is 10.5%, and transportation and warehousing will contribute 8.6% to the total cost. And of course, when we add these up, we get 100%. Looking at things in terms of a pie chart, we can see that the largest slice of the pie is contributed by the raw materials. That is 42%. Packaging contributes the second largest amount to the overall cost. Labor is third, overhead is fourth, and transportation and warehousing at approximately 9% is the lowest component in this pie chart or pie diagram. Pie charts give you a visual representation of the contribution of each cost factor. You should attack the largest cost contributors first. You also need to resist the temptation to focus on labor first. At 17%, it actually ranks third. In our example, raw materials warrant the closest look. Once again, they contribute 42% of the final cost of the beverage. Packaging is the next largest contributor to the overall cost at 22%. Skilled labor is really an asset, so you need to move on to the other factors first. You may want to find ways to improve efficiencies, which also applies to your labor component. When making adjustments to costs, do not tie the margins to the total cost as a percentage. The amount of your margin will decrease if you do that. So keep your margins at the same amount in terms of its dollar value. In our example, the cost per container was $1.74. Originally, we assigned a 25% margin that gave us about 43% profit on each container, which would then sell for $2.17. This is what you would charge to your customers. However, if you reduce your cost to $1.60 per container and still keep a 25% margin, your profit would be reduced to 40 cents per container, which would then sell for $2. In reducing the production costs, you have actually lowered your profit per container. Therefore, you should start off with a reasonable margin based on your initial production cost and assign a percentage to it, but then keep this value as a constant. That is to say, I always want to make 43 cents per container. Use your reduced cost, that is $1.60 per container, and add your 43 cents profit per container to get a new price to charge your customers. That would be $2.03 per container. Or better yet, keep the price to your customers at $2.17 per container and increase your profit to 57 cents per container. But do not give away your profit or reduce your profit. You are not in business to lose money. So we then opened the floor for discussion at this point and discussed how to reduce the cost of your production. Thank you very much.